Ever wondered what the Earth was like millions and millions of years ago? Hi there, my name is Gabriel, and today I'm going to be talking about continental drift. So, what is continental drift exactly? Well, continental drift is basically the theory that explains how continents move around on Earth's surface. But how do we know that this theory is in fact true? There are many pieces of evidence that can be used to support this theory, but I'm just going to be going over three. First, that the continents feel like puzzle pieces. Second, that there are matching rock ages and types of rock across continents. And third, that there are matching fossils among continents that are far apart. So, for the first piece of evidence, it's pretty self explanatory. Certain continents, such as South America and Africa, just fit together perfectly, like pieces of a puzzle. So that led scientists, specifically Alfred Wegener, to theorize that all of the continents were once one big continent, which is what we now know as Pangaea. Now, Pangaea is a hypothetical supercontinent that includes all of the current landmasses put together like pieces of a puzzle, and it is believed to have been in existence before the continents drifted apart during the Triassic and Jurassic periods, which is when the dinosaurs were roaming the Earth. But now, how did Pangaea, this huge supercontinent, just break apart all of a sudden? The Earth is a dynamic and constantly changing planet. The thin, fragile plates slide very slowly on the mantle's upper layer. This sliding of the plates is caused by the mantle's convection currents slowly turning in a circular manner. This overturn is like a conveyor belt that moves the plates of the crust around and around. The movement that happens today is the same movement that caused the plates to move slowly across the surface of the Earth back when Pangaea was around, and is the reason for why Pangaea broke down into the 7 continents that we now know today. Anyways, back to the point of the video. The second piece of evidence is that there are matching rock ages and types of rock across continents. Now, this piece of evidence is actually very interesting, as basically the idea is that similar rock types and those rocks' ages were found in different continents that were nearby. For example, many rocks from Argentina were identical to those found in South America, and the only justification for that would be that millions and millions of years ago, that piece of land that contained those types of rocks spanned across Argentina and South Africa, meaning that the continents were in fact linked into one supercontinent. Lastly, the third piece of evidence that supports continental drift is that there are matching fossils among continents that are far apart. So this piece of evidence is similar to the last piece of evidence in that both consist of items of similar ages being found in separate continents. However, this is different because here we're talking about fossils specifically, which is actually more complex than the last piece of evidence. So for this piece of evidence, matching fossils preserved in rocks of the same age were found on different continents. One more thing that I wanted to mention before this video ends is seafloor spreading. In 1912, when Alfred Wegener proposed that the continents had once joined together and had split apart, the biggest weakness in his hypothesis was the lack of a mechanism that would allow continents to move through ocean basins. At the time, everyone believed the oceans were permanent features, and at the time of Wegener, there was no credible explanation for a way the continents would have plowed through the rocks of the seafloor. But in 1962, a U.S. geologist and Navy Rear Admiral named Harry Hess came up with an answer. Rather than plowing through the seafloor rocks, Hess proposed that it was the seafloor itself that was pushing the continents apart. He believed that the location and topography of the Mid-Atlantic Ridge was not a coincidence. The ridge, he thought, was where the new seafloor was being added to the Earth's lithosphere, which in turn pushed the continents apart. Hess called it seafloor spreading. Hess argued that the Mid-Atlantic Ridge was a boundary where two lithospheric plates were rifting. As that happened, rising magma from the upper part of the mantle filled in the cracks that formed the Earth's crust. After the magma solidified into basalt and igneous rock, additional rifting pulled those rocks apart too. In effect, Hess proposed the existence of a magma-driven conveyor belt that continually added new seafloor, very slowly over time, widened the ocean basin, and pushed apart the continents to either side. In conclusion, the theory of continental drift seems to be true after all, because of, but not limited to, the three pieces of evidence that I discussed today, being that 1. The continents feel like puzzle pieces, 2. There are matching rock ages and types of rocks across continents, and 3. That there are matching fossils among continents that are far apart. Using these pieces of evidence and many others from the past, we can infer that the theory of continental drift will continue to exist in the future of our planet.